Greetings, ladies and gentlemen. Welcome to the Vajra series lecture titled as Agreement and Leader Election in a Distributed World by Professor Gopal Pandurangan. Gopal Pandurangan is a professor in the Department of Computer Science at the University of Houston. He received his PhD from Brown University, Masters from SUNY Albany and BTech from IIT Madras, all in computer science. He has held faculty and visiting positions at NTU, Brown University, Purdue University and Rutgers University. He is currently a Vajra visiting faculty at IIT Madras. His research interests are in theoretical computer science, focusing on distributed computing, networks, large-scale data and computational biology. He has made significant research contributions to the theoretical and algorithmic foundation of distributed computing and networks. He has also worked on the development of algorithmic foundations of dynamic networks. He has published over 100 refereed publications. His work has appeared in premier journals and conferences in the field including JACM, SICOMP, ACM, TALG, STOC, FOCS, SODA, PODC, SPAA, INFOCOM, and RECOMB. His research has been supported by research grants from the US National Science Foundation, US-Israeli Binational Science Foundation, and the Singapore Ministry of Education. Let us welcome him with a big round of applause.
Thank you. Thanks for having me here. I mean, it's been a wonderful time here being a Vajra faculty for the last 2 months. So I really enjoyed it. I was able to make a lot of collaborations. But of course, I was primarily in the CS department. Any CS guys here? Or okay, good. So although this is a CS-centric talk, I mean, I've made it sort of accessible to a more general audience. So any questions or anything, I mean, even if you're not CS, because some of the concepts that I'm going to say here, I think is going to appeal to a larger audience, not necessarily CS folks. So please feel free to just ask me questions. I mean, if you have any, just feel free to interrupt. Okay. So what is a distributed world? I mean, we basically live in a distributed world where everything is interconnected. Okay. So a distributed world is nothing but a collection of agents, devices, computers, people, whatever, connected through a communication network, and each agent has some goal which has to be realized through collaboration. Okay, so somebody wants to send email to somebody else, they want to send some money through some financial transaction to somebody else, so on. They want to send a WhatsApp message, whatever. So basically, people want to, the agents, which can stand for computers or nodes or devices, they want to communicate by exchanging messages via links. Okay, so basically we are living in a distributed world, and the model that we use for a distributed world is a network. So basically for us, a network is a distributed world, and a network is an abstraction of the distributed world where you have, so these two are examples of networks. Okay, where nodes, which you call, these are the nodes. Nodes are representing computers, agents, people, etc. And edges, these are the edges that connect nodes. They are the communication links. Okay, and neighbors are, so the neighbors of this node are the nodes that are directly connected to them. So these are the neighbors for this node because they are all directly connected to this guy. And neighbors communicate by sending messages. So for example, this guy can be, this might be just you, and these are the neighbors who are your WhatsApp, who are the people in your WhatsApp contacts. Okay, so those are the guys who can directly send messages to. Okay, so this is the model that people use. I mean, so this is just simply an abstraction of the distributed world. Okay, a network. And I've been telling this, so we live in a distributed world. So everything, so if you look at basically almost everything in this world, it is not one but many. So, and they are all communicating with each other. So the prime example of a distributed network is communication network, where, for example, the biggest man-made network is the internet, which we use every day. So it's just a network It's communication network of all kinds of devices, from your computers to smartphones to whatever, okay? And telephone networks, cellular networks, okay, and so on. And you also have distributed information networks that we use every day. For example, when you log into your bank account, you are a client who are connecting to a server which is on the bank side, which is trying to answer your queries, okay? So banking systems, airline reservation systems, these are client server systems, okay? So this obviously, it's all part of our world. And there's also another kind of network which is increasingly part of our life. It's actually been around for almost 15 years, called peer-to-peer networks. So here agents, instead of a centralized communication like client-server thing, here everybody is a client or a server, everybody communicates with each other directly, okay? So examples of these are Skype, right? So you Skype somebody and you talk directly with somebody else, okay? BitTorrent is a very popular file sharing system that uses peer-to-peer. So one of the craze these days is Bitcoin. It's a digital money. We'll talk more about Bitcoin. So it's a peer-to-peer network. Okay. So peer-to-peer technology has been sort of exploding in the last 15 years. So a lot of applications that have come. Okay. So and this is a very good example of a network. Okay, where everybody communicates with each other in a completely decentralized way. Okay. So again. So distributed networks need not just be made of computers, okay? So they can just be people, so social networks, okay? So where it's just simply a distributed network of individuals, where the nodes are just people. For example, friends network. So I am a network where the nodes are just people, and your direct connections are people who are just your friends, okay? So you talk to your friends, so that's where your links are, okay? Your edges are links, okay? So your Facebook or WhatsApp network, they're all social networks. So even you can have a brain network where you have a distributed network of neurons, and there can also have biological networks where bacteria, the nodes are the bacteria, and they communicate with other bacteria that are close by, so by cell-to-cell communication. So it has been recently found that even bacteria, they use agreement to do something in their world. Okay. So today's focus, of course, distributed computing or distributed theory of distributed computing is basically trying to understand the foundations of what a distributed network can do, okay? So it's a pretty vast field, but today I'm going to focus on two specific problems which are fundamental to the field, and one is agreement. So basically in agreement, loosely speaking, it's simply all the nodes or all the participants in the network have to agree on something, okay? And the other one is also in the title, lead election. So participants have to elect a common leader. I mean, we all know that in a democracy, we elect a leader. So similarly, in a network, there has to be just one leader. Okay, so both problems are very important in many applications. We'll come to that, we'll see that. So let's be a little bit more specific about agreement. So what is agreement? So in agreement, you have a network. Nodes are, I'm going to use nodes, so they can stand for people, computers, or whatever. So each node proposes a value, okay? And the proposed values might be different. So everybody might be proposing something. So I might be proposing A, somebody might be proposing B, and so on. But in agreement, the goal is all the participants eventually have to agree on one of the proposed values, okay? And this is not so trivial because everybody is not good. So it might be the case that not all of them are good. So some people who are really bad might try to prevent agreement. And we'll see that agreement is a crucial thing in many systems. Okay, so that's agreement. So you want to end up agreeing on a value, which should be one of the proposed values. Okay, so what is lead election? Simple. So your network, again, participants or nodes have to elect a unique leader. So there might be millions of nodes, but just one unique leader. Okay, and all the nodes have to agree on the leader. So just like we agree on who is the prime minister, he is the leader. So there's one unique prime minister, he is the leader, everybody agrees on that. And the point is, lead election and agreement, they are very related problems. They are not exactly the same, but they are quite related. For example, you can, if you solve agreement, you can solve lead election, because in agreement you can, instead of proposing values, the values can be names. So everybody can propose a name. So for example, they can propose themselves to be a leader. And finally, only one has to be agreed on. And that common agreed value is the leader. Okay? So similarly, lead election can solve agreement. Okay? Because once I elect a leader, that leader can just choose this value and say that, okay, this is the value that everybody has to agree. Okay? So in some sense, they are equivalent. So one can solve the other. Okay? So any questions? So the first part of my talk, like the first 25 minutes or 30 minutes is going to be very basic. So at least it's going to cover some of the basic stuff. So any questions now, it's a good time to ask. Okay. So why do we need agreements? So, and this is a very important question. So if you have a network and you have values, why do you need to agree on one particular value? Okay. So let's take an example to illustrate why we need agreement. Okay. So banking systems. So banking systems, they don't use one machine. So your data, the complete records are not in one machine. The problem is if you use one machine, if that machine fails, the entire bank is shut down, right? So banks use multiple machines for fault tolerance, okay? So you replicate the same data across many machines. There might be machines, tons of machines in Chennai and some in Bangalore, New York, whatever. The same data is replicated because if one machine fails, some other machine can serve the request, okay? But the problem with replicating is once you replicate data, then the data has to be consistent. So my account balance should be same across all the machines. It should not be different, okay? Otherwise there will be a problem, right? So the machines have to agree on the data. Otherwise it will be inconsistent, okay? So agreement comes naturally, okay? So, and this is one of the key reasons why agreement is used in many systems, okay? So the banking servers which replicate data, they run some agreement protocol to make sure that all the data is consistent at all times, okay? So the various agreement protocol, Paxos is one thing I'll mention a bit later. So it's used by Google, Microsoft, IBM and so on, okay? And the reason why agreement is non-trivial is that agreement is much easier if everybody is good, okay? So all the machines are behaving perfectly. There are no faults or nothing, okay? But once some machines are faulty, that means they either just malfunction or maybe it's been hacked, so they are malicious, so they want to do something bad, then agreement becomes very non-trivial, okay? So it also becomes non-trivial just because, not just a faulty, but just because machines are operating at different speeds. So you might see that then there might be problem having consistency at the same time. So you have to account for this. So things might be operating asynchronously, not at the same speed, okay? So that's what makes agreement a very non-trivial problem, okay? So another outstanding example of where we need agreement is the blockchain system. So I'm going to talk a little bit about blockchain, which is one of the very hot topic these days. I mean, everybody talks about blockchain. I mean, in fact, more non-CS folks are interested in blockchain, okay? So what is blockchain? Blockchain is simply a distributed ledger, okay? It's a public ledger where instead of having one central authority storing your data, for example, if I am in a bank account, so all the things that we do today, all the systems we do today are mostly not blockchain based. They are actually centralized based, right? So if I have my bank data, everything is in the bank. So it's a central authority of the bank which controls all the data, okay? But in a blockchain, there is no central authority, there is no bank. All the data is completely distributed, okay? And so this requires a completely new set of ideas, okay? So for example, an outstanding example is Bitcoin, okay? Bitcoin is a completely decentralized money. It's worth close to half $1 trillion now, okay? So agreement is the key thing we'll see, and the point is in blockchain, the entire bank, for example, if you look at money, all the complete money accounts of everybody in the world, if you're using, let's say, blockchain, is everybody has to agree on that. The entire accounts of everybody knows about it, and it has to be agreed by everybody, okay? So it's no more secret in that sense, okay? So we'll come to that in a second, but that's what blockchain systems is, and agreement is very important. It's the art of blockchain, okay? And this is again very non-trivial to accomplish when you have bad users, okay? So let's look at why do we need lead election. So lead election is slightly more easier to even understand, because in lead election, of course, we need that in a democracy. I mean, everybody cannot be running the country. Only one person can run it, or few people. So it's a symmetry breaking. So one person out of many people want to become prime ministers, but only one can become. So only one, so it's a symmetry breaking protocol. So obviously it's used in many applications. So one of the earliest applications was in a token ring network. So earlier, when this is now extinct, but before 10, 15, 20 years back, local area networks used token ring protocol. So there, when some node, some computer want to communicate with some other computer, it has to have a token, okay? So not everybody can communicate at the same time. So you do a leader election to determine who has the priority to communicate, okay? So token ring is largely extinct now because Ethernet is coming, Ethernet has taken over, but that's actually one of the reasons why leader election was important, okay? It started with that. But leader, once a leader is elected, it can do a lot of things, right? Like the prime minister is the coordinator, so he runs the country. So he can do various things. So that's why leader election is naturally important. And there are many real world computer applications. For example, Akamai is I don't know whether you know about Akamai, but Akamai is used whenever you are accessing the web. Akamai is most likely involved. So Akamai is a content distribution network that makes web access very fast. Okay, so Akamai uses leader election crucially to do this. Okay, and of course Paxos is used in many systems for consistency, and it also uses leader election. Okay, so let's come to blockchain, which is because I want to talk about it because it's an important sort of one of the hot topics these in the last few years. Everybody talks about blockchain now, and people think it has the potential to completely change how we do business or do everything in the world today. Okay, so what is blockchain? So in the current system, okay, so in what we have now is a centralized system. Okay, so let's say if I have my, so let's say look at land records. So one authority in Chennai, for example, the Chennai Corporation, they control all the land records. The central authority. If somebody wants to verify if somebody owns the land, then you go to that authority and verify it. Okay, that's a centralized ledger. Okay, it has the complete ledger of all the records, and there is a centralized verification. Okay, but in blockchain there is no central authority, right? So here there is a central authority, but here there is no central authority. Everybody is completely, there's no central authority. They're just people, and it's completely decentralized. So how can you do some verification? Okay, so the ledger is completely distributed. So all the land records, for example, is this, it's common knowledge. So everybody knows the land records of everybody. Okay, so if there is some transaction that has to be updated so that is reflected across everybody. So nobody has to go to anybody, right? So you don't have to go to a central authority and pay him and find out who owns the land all. Everybody owns that automatically. Okay, so that is the power of blockchain. So that's why people are now trying to use blockchain for various things. So it can make it completely decentralized with no central authority. Okay, so yeah.
So in the case of centralized, say the database containing all the details, credentials of the records is on server.
Correct.
If we take the decentralization, does that mean the database exists with every individual?
Right, every individual. But
the infrastructure for the individual entity has to be increased.
Correct, that's true. That is true.
So how is that issue? So how is that issue handled?
So that issue is a separate issue. So for example, somebody might handle it. So I might pay somebody to handle that, right? So I might pay a small fee for some cloud guy to handle that, to keep my data, because it's so big, because I'm having entirely all the data. Okay, but the more important problem is not that. The problem is, since everybody has the data, they have to agree on that, right? So I might just have, I can just write all the land to myself and just have that data. So the other guy can write all the land to himself. So, but it has to be a consistent data that everybody has to agree on. Otherwise, you can cheat. So that is the key problem. So agreement is the key problem here. So everybody has to agree on the data. Yeah, the volume of data is a separate issue that can be solved by other things. Okay, so let's quickly look at how Bitcoin works. I don't know, anybody who has heard of Bitcoin? Okay, nobody's heard of Bitcoin? Okay. Huh? Yeah, it's a cryptocurrency. So Bitcoin is, unfortunately, the Indian government is sort of, I won't say, I don't know, they are not promoting it, but Bitcoin is worth some of $500 billion today. It started about 10 years back. It's a completely decentralized. So there's no bank or country which supports the Bitcoin. Okay, so how does so it's a blockchain. So blockchain started with Bitcoin. So it's an example of a blockchain system. Okay, so here instead of land records, I'm having the entire money records. So everybody's money is completely distributed. Okay, so how does Bitcoin work? For example, if somebody wants to, let's say person A wants to send some money to person B. Okay, so he will basically make the transaction. Say I'm going to give that money to B, and yeah, you will just send the transaction. You will write the transaction in a sort of what is called as a block, and just send it to everybody, okay. So send the block to everybody, okay. And what happens is this block, of course anybody can just write anything and say, I mean, I got some money, you got some money, but it has to be verified, okay. So this is where I do agreements. So all people in the network have to approve that the transaction is valid. So for example, valid means what? If A sends $1 to B, A should have enough money to make that $1, okay. So that is one validity, okay. So that has to be verified, okay. And also you have to make sure that A does not do double spending, okay. This is the key problem in if you have a distributed ledger, right. I can use the same $1 to buy two different things. Of course, in the even in the centralized setting, that is not possible because I'm using a bank. I can't use the same $1 to buy this two different things. Okay, in a distributed thing, I can send $1 to A and same $1 to C. Okay, and get two for the same dollar, get two things. This is called double spending. So this is a serious problem. So this is not possible if you do if everybody has the complete ledger. So I can check because this guy sent $1 to this guy. You cannot use the same dollar to another guy because everybody has the complete record of all the transactions in the entire network. Okay, so everybody has to agree on that. Okay, and once everybody agrees on that, then this thing can be added to the blockchain. So this is called the blockchain. That's why that name blockchain is. Blockchain is nothing but a chain of blocks. So this blockchain is very large. For example, for Bitcoin, the Bitcoin started in 2009 or 2008, and the block, this is the latest block. If you go to the end, it will go to 2008. From the very first transaction, all the transactions are recorded in the block. So you cannot cheat because completely all the transactions there, everybody can see the transactions. So all the records are there and everybody has that, so there's no question of cheating. But you have to agree on this blockchain. Okay, so that is basically Bitcoin in a nutshell. Once this transaction is approved, then the actual transfer, okay, so everything is verified, so now the money actually goes to B. Okay, what happened? So let's look a little bit into, so that is sort of in a nutshell, okay. There are a lot of details that I omitted, okay. So I cannot go through all the Bitcoin stuff today because not talk about Bitcoin, but let me talk a little bit about it, okay. So there are hundreds of transactions. So in Bitcoin, if you go, there are typically about hundreds of transactions per minute, okay. And they're all collected together in one block. So you don't do one transaction per block because it's too time consuming. So you collect a bunch of transactions and then do a block, okay. And the key thing is adding a new block to the blockchain is costly. This is where the agreement is sort of enforced. I will come to that in a second. But to add a new block, somebody has to do a lot of work, and this is called proof of work. Okay, so he has to do a lot of work to add it. So I can't just cheat and say, okay, I got this money, I'm going to send this money and so on. Otherwise I can do double spending. I have to do a lot of work to add the block to the blockchain. Okay, and why should somebody do a lot of work? Okay, the point is, the ingenious idea is that when you do a lot of work, you also get new money. So actually that is the way you generate new Bitcoins. Okay, and that's a reward for adding a new block, and this is called mining. Okay, and this is a very ingenious system. So nobody knows who started Bitcoin. This is some anonymous guy, not fictitious, is anonymous guy. Nakamoto, he wrote just a paper in 2008 saying that this Bitcoin, okay, and it has taken off in 10 years, it's worth $500 billion. So nobody knows who this guy is, but that's a very ingenious way to do this agreement, okay. So the key idea is he uses this proof of work to do agreement, okay. So point is all nodes have to agree on the validity of the new block, otherwise people will cheat, okay. And any node can propose a block, right? So anybody can propose a block, but the point is it has to show proof of work, okay. And what is proof of work? Proof of work is simply a way to enforce agreement under presence of bad participants. That's the problem. So if everybody is good, then you don't even need central authority. You don't need a bank, you don't even need this complicated agreement. If everybody is good, then things can be much easier. But the point is there can be a lot of bad guys who might try to cheat. Right? They can do double spending or do whatever, okay. And the proof of work is simply, it's a very costly way to generate. So the work has to do, the node which tries to generate this new block has to do a lot of work. That's why it's called proof of work, okay. So why it's proof of work? Because it's very costly to do but easy to verify. So all nodes can easily verify and validate the block. So it's easy, it's a kind of a problem, it's a mathematical problem where it's hard to do, hard to accomplish. It's like creating music, right? So it's very hard to create a music, but it's easy to appreciate it. So it's something like that. Okay, it's very easy to appreciate music, but it's very hard to create music. Okay, so all nodes can easily check, okay, this block is correct because it checks some formula and checks this is correct. So easily all nodes can verify, but it's difficult to generate. Okay, so this makes very difficult for the bad nodes to cheat, because if they cheat, they have spent a lot of work trying to cheat. So that's not pointless. I mean, that's pointless for the bad nodes. Okay, so this really prevents double spending. So there's no point cheating basically. Okay, so this was done. This proof of work concept is a very nice idea. It goes back to several years. Okay, and so basically proof of work, as I told, is a computationally hard problem. It takes a lot of power and it consumes really a lot of electricity. Okay, so not everybody can do. Okay, so this mining is done. You need a lot of resources to do mining. Okay, that means creating a new block. Okay, and very few nodes have the resources to do the mining. Okay, and it's very compute intensive. Okay, so it's now said that the Bitcoin electricity consumption of Bitcoin is more than about 159 countries. Okay, so the Bitcoin electricity consumption is probably as big as Tamil Nadu's electricity consumption. Okay, and most of the Bitcoin is in China, so they burn a lot of coal to do the mining. So most of the mining power is now in China. Okay, so it's a very compute intensive thing. Okay, so Bitcoin does do agreement, but the point is, why is it so difficult?